Hello everyone. In this video, we will talk about planar kinematics of a rigid body, forces and acceleration. So to get started, um, if you remember the parallel axis theorem to find the centroid, now we can use it over here to find the moment of inertia, which says basically I of at any point is Ig, which is the center of gravity, plus md squared. And also there's another equation for that, which is I equals mk squared. Now what is k? K is a term called radius of gyration. Now usually you would only use this equation if the problem state that okay, you have a radius of gyration of blah 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 value, and also, well, from the previous equation, k equals the square root of I over m. Now let's keep going. So the sum of the moment about the center of gravity is Ig times the angular acceleration alpha. And the sum of the moment for the external forces is also equals to the sum of the kinematic moments about that point, about any point speed. Now this is going to be used later to basically, well, to find whatever value we're looking for. Now let's say we have a problem with translation. This is when we have a body only moving in the x direction, only moving in the y direction. It's not rotating. There's no rotation here. So we have, if we remember, sum of the forces in the x equals max. Sum of the forces in the y equals may. Now notice ag. We're working on rigid bodies now. We're no more working on particles. And the sum of the moment at the center of gravity is 0. Let's keep going. So, curvilinear translation. What is that? So let's say we have a body. It's translating on a curve. So this body is only going there, now it's here. Notice it's the same. It didn't rotate, so it didn't become like this. It stayed like this. So it didn't rotate about its center of gravity. So we notice the same thing as before. Now we have normal and tangential. So sum of the forces in the normal equal MAGN. Sum of the forces in the tangent, MAGT. And sum of the moment about G equals 0, since it's not rotating about its center of gravity. Now these are very simple equations, so kind of going over them a bit quickly. Now let's say we have this body rotating about point A. We have this about point O, so we have the center of gravity G over here. We have angular velocity double omega, angular acceleration alpha. So sum of the forces about the normal is m omega squared r. Now notice this is actually MAGN, and AGN is this omega squared r. So sum of the forces tangential equals m alpha rg. Alpha is the angular acceleration, and sum of the moment about the center of gravity is Ig alpha. Sum of the moment about point O is IO alpha. Now notice, if you remember from the parallel axis theorem, IO equals Ig plus md squared, and this would be d. Now let's use all of these in an example. So let's say we have this box, a cube to be exact. We have a force 600 horizontal, which is 0.8 from the ground. We have the weight 490. Well, the mass is 50 kilograms. And so we want to know what is the reaction, what is the distance x that the reaction is acting on, and what is Ag. Now we don't want that. We want at the moment before it tips. Now if you look, if you exert a force over here, the box is gonna tip unless we have some of the forces corrected. Now we do the sum of the first. We do sum of the forces about y equals 0. We only have the weight and we have NC the reaction. So NC is basically the weight, 490. Next, we can do the sum of mg equals 0. Notice we don't have a rotation here. That's why it's equal to 0. So g is over here. Now we can do, so we have the 600 minus 600 times 0.3 plus nc times x minus 0.2 nc, which is the friction. 0.2 is mu k. It's given in the problem. And times 0.5, that's the distance, though everything is equal to 0. Now we already have NC from before. We get X to be 0.467 meters. And the last thing, we do the sum of the forces in the X direction, which is MAG. So we have 600 minus 0.2 NC. We already have NC equals MAG. We have the mass 50. The only unknown is AG, and we get AG equals 10 meters per second squared. This basically sums this chapter. Hopefully this helped. Thank you everyone for listening.